So, good morning, good afternoon, welcome, and thank you so much for joining us here today on the Insider series. I'm Ernst Kratky from the EMEA Compute and Cloud team. With me, my colleagues Andrew Gagnon and Sergio Susha. Today, we are talking about hybrid and computing for the age of hybrid cloud, specifically when we are diving deep in all the details on the recently announced UCS series. This is the all-new flagship modular computing system from Cisco. It's all about managing from the cloud, across the cloud with Intersight. So let me kick off. Our strategy at Compute has always been to look at the key changes in the industry and develop architectural solutions that enable our customers to navigate that journey. So if you look back about a decade or so, we started the journey with UCS. And the main trigger, if you remember, at that time was virtualization and consolidation. We really developed UCS as a system that brought compute, networking, and storage together in a so-called unified architecture, with key innovations such as a fabric-based computing model or a single wired management function, stateless compute, and a disaggregated management model that enabled both scale and design flexibility. As we evolved this, we saw the next wave of evolution a couple of years ago coming with the data explosion. So the data explosion also led to a lot of scale-out designs, software-defined designs, the evolution of hyperconvergence, and a couple of workloads like big data and AI and machine learning and a number of other workloads that really changed the industry in this area. The systems approach we took in our original design has served us well also in this transition. But if you look at where we are going as an industry today, the next big transition is about everything hybrid. The hybrid cloud, hybrid application, the hybrid operating model. It's about moving towards more hybrid IT. And not only is the operational side of things becoming hybrid, the other big change we are seeing is the change in technology at platform level. And this is very, very disruptive. If you look, for example, at PCIe 3, which we have had for a decade or so, and we are going to PCIe 4 and 5 and 6 in 3 to 5 year period. That is pretty fast for platform transitions. Or another big trend around CL looks really promising for the next evolution in the ability of disaggregation. So being able to assemble in real time compute and storage and peripherals in a system on the fly. And that is a massive, massive change. And of course, accelerate this. Accelerate with GPUs or FPGAs or even the new trend of advanced smart NICs. All of that is making customers think about their application and their system design. And at Cisco, so no surprise, we are also seeing the transition from 100 gig to 200 gig to 400 gig networks in the near future. All of these changes in technology require a platform architecture that enables customers, so you, to manage these transitions, as well as have a management model for the next decade. This is the true inspiration why we have built the new UCS X series platform powered by Intersight. It is truly built to navigate these transitions as we see coming. I just want to give you the biggest context of this, as you will get more details and insights from Andrew and Sergio later. There are three key tenets: flexibility, cloud operations, and future-proof. So that is in a nutshell the promise of the new UCSX platform. With that, I hand over to my peer, my friend, Andrew Gagnon. Team, please pass the ball to Andrew.
Good morning, good afternoon, good evening to everybody. Thank you for your time. Just to reiterate what Ernst has just said. So what I want to do is I want to spend the next 20 minutes or so just exploring what X Series is about, why we've done what we've done, some of the key benefits, and also a bit more about future direction before we then move on to a demo of Intersight. So without further ado, I'm just going to start my slides. So why are we doing this? Why does Cisco want to introduce a new generation of platform? Well, in a nutshell, what we are seeing is a massive explosion in the number of applications that are being used, and the fact that these applications are not specifically in one place. They can be on-prem, they can be in a private cloud, they can be in a public cloud. It doesn't really matter now these days. But what that does do is that puts enormous pressure on the business to make sure that everything is as agile and as efficient as possible to allow us to be as dynamic as possible. As you all know, we've all got smartphones, and when you have a better application comes along, very quickly you'll just click and you'll move to something else. So again, you need to have that flexibility to be able to do things in real time, which we just haven't been able to do based on some of the models that we've built over the last 10 years. So this is an and presentation, and the product is an and product, so it adds and complements what we already have today. So from a application point of view, we're going to see a huge increase in the number of applications, as I've said, and that is going to put more and more pressure on. And if you can't move as quickly and be as agile as the competition, then obviously that causes a potential challenge as well. And the other thing is, from an operational side of things, things have got very, very complicated inside the data center. And there's a lot of fragmentation, not just from a hardware point of view, but also from a software-defined platforms in terms of how you layer on your applications. So if we can't help you try to simplify your operations, and we're not just talking about the initial configuration, but what we can do in the future, then that means that you're not going to be able to take advantage of all of these technologies. And then from an agility point of view, one of the key things that's becoming more and more apparent is we need to basically turn the compute element into a software as a code. So be able to code this in real time using service profiles that we've built over the past with our previous systems to allow us now to basically not just look at the processor and the memory, but also look at GPUs, FPGA cards and storage. So we need to be able to just really start to disaggregate the hardware platforms to allow us for you to present the applications with what they need at the right time and make sure it's fully compliant. Now, as Ernst said earlier, there is huge churn in terms of the technology that's being offered. I'll just give you an example. So PCI 3 has been out for a long, long time. PCI 4 has just been introduced with Intel. AMD have had it for about 18 months before. This time next year, we'll be up to PCI Gen 5. So what we're trying to show here is that the shortening of the life cycle of a lot of technologies. CXL is a very interesting technology. This will ultimately allow us to, for example, share memory across servers, but also to have an external device that's just full of persistent memory. So you imagine that you just have a block of memory that you chop up in software to allocate from a performance point of view. So again, giving you the flexibility, you don't have to buy a dedicated box to do a dedicated workload. From a GPU and high wattage, if you look at M3, M4, they were typically under 100 watts type processors. We're already at 270 watts with M6. By the time M7 comes along, we will definitely be north of the 300 watt side of things. And GPUs, we can see that heading towards the 500 or 600 watts. So again, a huge increase in density, but also an increase in the power consumption requirements. As Ernst said, networking. So if any of you are as old as I am, and you remember when we first launched UCS, it was quite radical because it was 10 gig, and we had a lot of customers that were still running 1 gig inside their primary networks. So you can see the acceleration to 100, 200, and 400 is becoming more and more prevalent. So we need to be able to design something that allows us to take advantage of all of these technologies without you having to rip and replace, because you're not going to do it. And obviously we need to give you that flexibility to keep up, but without having to sacrifice all that investment that you're going to make. And obviously smart NICs are becoming a thing as well. So if I look at this very simplistic diagram, the complexity within the data center is fragmenting. So if I just look at the compute side of things, initially we had blades. And a lot of customers bought blades because it was very simple. It was easy to wire, single wire into a fabric interconnect, managed by a UCS manager, and it could do mission critical workloads. But over time, when things like VDI became more and more important and becoming even more important in the future, people started to buy rack servers because they had more space to allow them to add GPUs. And that allowed them then to meet those needs. And then we had AI and ML, and those started to see even more fragmentation and different products built specifically for that task. Big data is another one. So what I'm trying to paint the picture here is that the compute model has fragmented over the last 10 years, and it's become more and more difficult to actually reallocate and use those resources effectively. And then obviously you have multi-vendor technologies as well. So basically the management side of things has got really, really complicated. And that's exactly the same with the software infrastructure, whether it's an operating system, hypervisors, moving to containers, trying to look at storage and all those things. This becomes really, 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 really crucial to look at how we can modify and fix this environment. So what we have now is complexity, discrete pieces to do specific types of work. It adds an additional cost. So for example, if you needed an application decided it needed an additional set of GPUs and you couldn't fit them inside the existing server that you'd already allocated, you'd have to buy a server, metal box, power, supplies, processor, memory, before you actually get to the GPU side of things. So again, that means that that's difficult to do. It means you've got to stand it up. It means you've got to build it, wire it in, make sure you've got a window. It just makes it very small. So in effect, what you do in human nature is like this: you will over-provision. You'll over-provision to make sure that you don't run into those things. But that has a cost, right? And there's also an administration side of things. But what happens when you've finished using that technology and you want to use it for something else? Is it easy to deploy? Is it hard to expand it and upgrade it? And obviously what that does is that it also gives us inefficient silos of different types of products, maybe from different manufacturers and power usages. So as a result, you just end up with something that becomes harder and slower to move forward. Now, if we look at management side of things, we think there's a huge integration opportunity to start to look at how we can combine a lot of those features, both from a hardware and fabric, into a single pane of glass. So we, Cisco, are putting our emphasis on moving to Intersight. So Intersight for this product and for anything new technologies like our AMD rack servers has to be used with Intersight. We've drawn a line in the sand, and I'll come back to why we're making those changes. But from a hardware and software infrastructure point of view, we want to use Intersight as our only way of managing and controlling these products. And there's some huge upsides in that model. But it also gives us a huge opportunity if we can design something that's simple, adaptable, in terms of basically you have resource pools that you can allocate via software, and make it much more cloud-like from an infrastructure management point of view. So we simplify the operations. It allows us to grow and shrink the workloads and the provisioning of the hardware and the software. And it allows us now to turn around and say, well, actually, we can now combine some of the workloads that drifted away from a bladed environment back into this because we have a new modular approach that allows us to have the same resource pools without having to buy specific discrete platforms and boxes. So basically, this is what we've done, and this is why this platform is so important. This is the X series, and as you can see, it looks a bit different from what we've done in the past. It's simplified because it's cloud operated through Intersight. I'm going to keep reinforcing that. It's very, very modular design, and I'll explain a lot more about why we think it's such a fantastic product and why we think it's so good for you from adaptability. But it's also future-proof. That's really crucial with all these changes that we've got coming. So just to give you an example, this is the chassis. Now, most of our competition will have a box like this, but all you put in here is power in the right-hand side, the resources that you need in the front, and then the I/O at the back. So all this is a big box to slide everything into and power it. There is no overhead. There's no streamers. There's no fixed mid-plane, which makes a huge difference to the flexibility of the platform and where it can go in the future. So it prevents any technology lock-in. As you can see, the airflow is pretty simple, right? It's just an empty box. Very power efficient. However, with what I've said about power consumption of both CPUs, memory, and GPU type products, you're going to need a lot more capacity in the future if you wanted to fully populate it. And you configure it for the workload that you want it for. And if you don't like that workload, you change it. But this gives us a high performance platform where we could support over 600 cores inside this platform. So to give you some context, an M3 type platform typically was around about 8 to 10 cores, less than 100 watts. So again, 40 cores, 270 watts. So there is a benefit, but the density goes up and so does the power consumption. So this allows us now to have a long-term roadmap without having to worry about whether or not you're going to lock yourself in, because you're not going to. So let's just go into a little bit more detail. So basically, we're going to call them nodes from now on. So I try to use the word nodes, but if I slip up with blades, that's just 10 years of bad habits. So as you can see here in this particular picture, you can see compute nodes. They sit vertically. We will in the future introduce storage nodes, and we'll also introduce PCI nodes as well. So we will now have the ability to not just put memory and compute in here and storage, as you can see, but we will be able to augment that in the future, and I'll come onto the roadmap with other types of technology. From an I/O point of view, basically what you've got here is the similar horizontal position of the IOM module that we've had in our existing blade environment. And this sits horizontal. There's a reason for that. And this particular diagram shows the 25 gig. So we're going native 25 gig. From a power and cooling point of view, because of the requirements of the future, we have designed this platform. If you fully populate the power supplies, you have over 16 kilowatts of power available. Now, before you think, wow, that's never going to fill a rack, this will replace racks of servers because of the sheer density. It has over 20 different cooling zones within the design, so we can actually look at how we modify the power and cooling, the fan speeds, etc., etc. It allows us to basically, whatever you put in it, we'll be able to keep it cool. It's designed up front to move to liquid cooling and photonics if required in the future. So again, all of the design has been really thought through as to make sure that you're never going to have to stop, rip, or replace something because you want to drive into a new technology. Now, the X fabric is the clever bit in terms of the new innovation. The current view you see here is PCI Gen 4, and this is a horizontal connector that allows us to for the servers to talk to each other. But in the future, it could be PCI Gen 5, you just replace them, or the CXL memory technology, when that becomes available and matures, you may decide that that's what you want to do and you want to hang an external device off the back purely just from memory point of view. So again, we've got huge potential, but as you can see, very simple, clean design that allows you to buy what you need to do to run your business. And then in the future, if there's a new technology that will help you run your business more efficiently, you can make those modular upgrades. So for example, if the IO, you decided you wanted to go native 100 gig, when we introduce that 100 gig connectors, then you'll just be able to upgrade those, and it will be directly connected to the server. So this is the really clever bit, right? The nodes sit vertical and all the connectivity sits horizontal. So they connect directly to each other. So again, we don't have this mid plane getting in the way. And that allows us, if you make the upgrade, you get the benefit. And that's really, really important moving forward. So from a compute node point of view, obviously with the latest generation of Intel processors, we've got 32 DIMM sockets. That's really important because if you look at the higher density of memory that you may require, if you've got 80 cores in there, you know, having full 32 DIMM sockets running at 3200 is really, really important. The drive thing's a bit more interesting as well. So what we're seeing is NVMe costs per terabyte are now below SSDs, can't get too much coffee. So as a result, you've got very high capacity now in a single node. So you could have 180 terabytes of raw storage. Now, if you think about that, that's a backup server. So that could be a cohesivity backup server in one device. And obviously with NVMe capacities increasing, you know, we expect to see a 50 terabyte drive in the not too distant future. Well, that's suddenly 300 terabytes. That's a huge amount. And then we use the VIC, which is our virtual interface card, to allow us to logically chop up in software how you want to communicate out. And you can add a second card, a mezzanine card, to actually double the throughput as well. In the future, we will offer, instead of a mezzanine card, a GPU. So we will be able to offer a GPU with inside this node. But one of the reasons we can do all this expandability is because we've turned it on its edge, and we've increased the size of the node quite dramatically. So just to give you an idea of where we're going, ultimately, you will have a choice as to what resource pool you want to place inside this chassis, whether it's a compute node, an accelerator PCI node, or a storage node. Now, there are different times for these as well, and when they'll be introduced. But obviously, the compute is announced now, and I'll talk about the other two in the future. But what we're basically going to give you is the ability now to chop up in software and allocate those resources for the application that you need. And then in the future, if you decide to change them or you need to add some additional resources, you can again do that in software. So it's going to be policy-based. It's designed for anything in the future. And basically the modular approach allows us now through Intersight to basically look at this as a complete resource pool. Whereas in the past, you may have had to have some blades, maybe some racks to do a lot of these workloads. You now can shrink them down. And obviously, because you're only paying for the bits that you need to use for the resource, makes a huge difference as well. So pictorially, it looks a little bit like this. So if you were running an AI ML today, you would buy a specific product, put some storage in it, some GPUs, have a bit of memory and some IO. Well, we can do that now through software, through the different resource pools. The same with VDI, very important workloads today, where you need storage and compute. Again, we can do that. And then obviously from big data, typically what you were doing is you were buying an awful lot of storage, some compute, and then basically you were buying dedicated rack-based servers because you need the storage density. Well, we'll be able to do that as well. So again, really, really important. So just to re-emphasize, very simple. You know, you add what you need, you use what you need, and then basically when you don't need to use it, you can reallocate it. Very, very simple. It allows you to have that agility that we've not been able to do for you before. And it gives you that flexible buying choice to be able to buy the resources that you need to be able to do that, all through Intersight. Intersight is crucial for us. So there's a number of things that we have worked on, and we've been very successful. Converged infrastructure being one of them. We worked very hard to try and reduce the time for you to get value from buying compute, networking, and storage, where we basically validated the designs. If you build it, if you buy this, we built it, we know it's going to work, and we'll guarantee it. So again, very, very important. And it's something we're going to continue to drive very heavily with FlexPod and FlashStack. From a technology partnership, we work very closely with Intel and NVIDIA, and there's a whole load of work coming here as well. From a CX services point of view from Cisco, there will be a number of services that we can offer to help you to look at what your environment looks like today, give some advice on migration, et cetera, et cetera. From a validated design point of view, we're going to move that forward. So we're going to start to do eCVDs, And what that basically means is instead of you having a book paper and having to type in all the codes, you'll be able to drag down the configurations and then modify them accordingly. So again, to try and help speed it up, better time to value. And then we have a number of tools around cost of ownership and sizing that we can offer to help you make sure that the migration from older legacy systems to the newer generation. So, you know, if you look at the consolidation ratio, you're probably about 3 to 4 to 1 from what you have to what you need in the future. So again, it allows you to really help you have a better outcome. So basically, from what we're introducing is we have the ability now to offer a new generation of server platform that complements our existing server offerings, but allows you now to have a much more modular and agile system moving forward. So high density workloads, a lot of the workloads that we particularly couldn't do on a bladed environment, we now can do this with this node, totally driven by basically a very simplified user interface with Intersight that allows us not just to stand the thing up from a configuration point of view, but also to look at the day-to operations, whether that's hardware compliancy, connected support, and a number of other different skill sets that we've got. The other thing that we're starting to see is an awful lot of customers are very interested to look at how this platform or how servers in general behave in terms of over provisioning and whether or not there is more resource that can be used if they were a little smarter. So for example, we have things like IWO, which allows you to look at whether or not you've over provisioned a number of servers to the memory and stuff like that, and then reallocate them or shrink them down, and then offer up the remaining resources to new workloads. So again, trying to drive that operational efficiency. If you're obviously really pushing hard on FlexPod and FlashStack, there'll be integration within Intersight that allows you to do all of the provisioning of the NetApp storage or Pure storage within Intersight. So you basically then can start to see that seamless integration, which is really, really crucial. So just to re-emphasize, if you look at what you've got from an M3, M4, M5, so that's our designation of previous generations of servers. We're obviously currently on M6. The ratio is anywhere between, I believe, 3 and 4 to 1 down in terms of number of physical servers required based on the new higher density platforms. So that will obviously save a number of things, not just on space. Power management actually will be better, even though it looks high with a very high 16 kilowatts of power. But basically, you're getting so much more out of that 16 kilowatts than you were in the past, and it helps with reducing costs. So, for example, you know, if you look at the costs of virtualization, you know, there's a definite sweet spot at 32 cores, right, in terms of how you can reduce down your licensing costs. So just from a timing point of view and a phased rollout point of view, obviously we've announced the compute nodes today, along with obviously the chassis, 4th generation FI, Intersight managed, and all that sort of stuff. Later on, we will introduce a PCI fabric node that will allow you to put PCI cards into a node and then allocate that through storage. We'll also obviously be able to do that with the compute nodes. And then next year, we'll introduce a storage blade that will be based around NVMe, probably PCI 5. And that will probably be timed when we start to look at the next generation of servers as well. From a timescale point of view, obviously first half, June, we've just squeaked it in with the launch of the X series. So we have customers doing field trials. We're going to start shipping in volume next month. So we've got to that point. In the second half of the year, and I'm probably going to earn more on the first half or very early calendar year 22, we'll see a next generation of VIC, which will allow us then to support a next generation of FI, which will be 100 gig native. And then we'll also have the PCI GPU nodes, depending on how you want to pronounce it. And then later on, tied probably to an Intel next generation of server, we will have a storage node, which will be based around PCI Gen 5. Again, please just want to, this is quite rare for us. We actually want to share where we're going. But again, there should be a big asterisk on everything that I've just said around the fact that some of it's not committed. That's internal speak for we're going to do it, but we haven't said we're going to do it, and we haven't got a date as when we're going to do it. And obviously there are subject to change. There's so many unknowns in this world at the moment in terms of supply of components, and we're subject to other people's timelines, specifically Intel or even NVIDIA, that some of these things are subject to change. But as our best stab at the dark right now, launch the product. Later on this year or very early next year, we'll have the PCI GPU node, and then later on in the year, we'll have something around a storage node as well. So just it's a very, very clever modular system. We've got a chassis that's 8 RU, so slightly bigger than the one before. Northbound of 500 cores, huge jump in memory because of the 32 DIMM sockets, a huge amount of storage because of the nature of the drives that we can put in there and just the physical number. The Fabric module is great because it gives us that ability to run 25 gig native and other speeds in the future. From a power and cooling point of view, I would imagine most customers, and the customers that are buying this now, they're typically buying four PSUs, that's N+1, because that's all they need right now. But in the future, obviously, if they went to higher wattage and they need more, they just slide in that. And then across the X Fabric is something that's really important for us because it allows us and you to move with the times without having to rip and replace, your resource pool and everything else that you've already invested in. So I just want to talk very quickly about Intersight because this is crucial. Intersight is the way we're going to manage this platform. There is no support for UCS Manager and UCS Central with the X series or the AMD rack servers. So why are we doing this? We're doing this for a number of reasons. The most crucial one is because we have, in effect, a database that's sitting on top of a Fabric Interconnect, you have to manage that as a separate point. And a lot of our customers don't necessarily use the latest and greatest shiny version of that software. And we have challenges and we have problems like everyone else does. But a lot of these times they're fixed in a newer version of the software. However, if it's not installed, it can still cause that problem. So there's a number of different things. Plus, it's written in a very old language. And as we move to a more cloud-like agility, we need to be able to have you switch on, and on a Thursday, there's a new update. You don't have to do anything. You don't have to feed it. You don't have to do anything. And it allows us to unify everything that we're doing into a single compute software layer. And that allows us then to look at new architectures, which I'll come on to in a minute. And there's no specific tools. So Intersight is a fully featured platform that allows us to support M5s, M6s, fourth generation FIs. And basically, we have a number of new services that we can offer and build into Intersight, like connected TAC or hardware compatibility. Because as we know, we all set these things up. You as customers spend a lot of time researching and developing and testing before you stand something up. And then that's fine. And then what happens if you have to make a change? How do you know it's compliant? Well, we can help you do that with Intersight. So we've got this day 2 operations to make sure that you're compliant, which is really, really crucial. More interesting, if you look at the management side of things, UCS Manager, as I said earlier, is a database and it sits on top of a Fabric Interconnect. So it's quite a large bit of code and it needs a lot of memory, which is why we have to use a Fabric Interconnect. And then for day 2, for operational side of things, you use Intersight. With the rack service, you have the individual AMC software, which basically allows you to manage your rack as an individual product. Kind of not as easy as it could be because obviously what you want is a universal code. So if you look at the right-hand side, it's a device console. It's a very small bit of code. And you'll notice that we've changed the wording to Fabric device. That's crucial. So we're moving from Fabric Interconnect to Fabric device. In the short term, that means it's a Fabric Interconnect, a 6400 family Fabric Interconnect. But in the future, it will become the option to have it as a Nexus and remove the Fabric Interconnect. Now, it needs to be a specific type of Nexus, and there's software and all sorts of other things that we're still developing. So at this particular time, I can't confirm a timescale for that. I would hope it would be sometime this year, early next year, that we will be able to give you the choice. And obviously, that fabric device can manage X series, 5108, blades, and our rack servers as well. So again, it's still got that ability to be to have everything inside the same domain. But you've got to use Intersight. You cannot use a UCS Manager or UCS Central. So just to summarize, we have a very simple new era of hardware and software. So cloud managed software that allows us to basically look after your estate wherever it is in the world through a single pane of glass. Very, very simple, very adaptable infrastructure. So the different types of hardware that you plug into this will allow you to have that resource pool that you can take advantage of. Easy to use and design, simplified through working very closely with our friends at NetApp and Pure, and obviously allows us to do not only the mission critical applications, but applications that typically would have gone into a different hardware format that you had to buy different things that you didn't need just to be able to get that resource pool. So Intersight driven, fully adaptable, and future proofed for your environment. I hope you found that useful and insightful. I'm now going to pass over to Sergio, who's going to show you Intersight. Thank you.
Thank you so much, Andy. Let me quickly share my screen here. There we go. So while I log into Intersight here, there's one thing that I would like to highlight again, which goes in line with as a follow-up with the conversation that Andy was having. So we do require Intersight to manage the X series platform. However, it doesn't mean we cannot manage other platforms from Intersight as well. Okay, so it's not an exclusive for the X series, right? It's the platform for us going forward to manage our infrastructure. So yes, we do support previous generations of our Blade platform. We do support standalone rack servers. We do support rack servers connected through the Fabric interconnects as well. Okay, so this is a key point that I would like to highlight because there were a few questions on the panel as well. So let me just quickly log in here. For those of you who know and are comfortable with UCS Manager, you'll realize that Intersight is different. Obviously, it's different on the model, the model of delivery of the application on itself. Obviously, UCS Manager was part of the Fabric interconnect, so it was an embedded application running within the fabrics, while Intersight is a cloud-native application that we provide as a service. Okay, while we do have versions that we can run on-prem, most of our customers are attached to our online version. And so for those of you used to work with UCS Manager, you'll realize that the GUI, the interface of Intersight is slightly different. However, I would say just maximize this to make it bigger for everybody. One of the things you'll realize is despite the fact that it's really different, there are a few things that you will realize are in fact similar to what we used to have and what we still have on UCS Manager. Now, you still have the constructs of pools, you have the constructs of policies, templates, and profiles. So the good old stuff that we developed with UCS Manager, it's still available on Intersight. Okay, so before we stand up a server, before we stand up a device, we first define what that device should look like. Okay, so again, the pools, the same as we had before and that we have today with UCS Manager, pools for IPs, for MAC addresses, IQNs, and so on. And then the policies. What you realize that it's becoming to be a little bit more different, or a little bit different, or at least let's say, more complete is the fact that we have additional targets and additional policies that we can configure today. So if we just ask to create a new policy, we can be selective and pick up a server, and we'll see the good old policies that we have on UCS Manager, the BIOS policy, the boot order. So we define the policies that leverage the pools, and then we build templates, and then from templates we deploy profiles that we assign to servers. Okay. Now, using this construct has been very successful in the past. You guys as customers, you like it, and we've been putting more and more into that. So today, for instance, we can use the same type of approach to create and manage Kubernetes clusters or Hyperflex environments. Now, the UCS chassis, we already had it on UCS Manager, and there is a new concept here, which is the UCS domain. And this is, I would say, cool. I like it, because in the past, as we deployed Fabric interconnect clusters, we would deploy them on the console and then move to a graphical interface where we need to set up each one of those clusters. We need to define the VLANs that we're going to allow. We define the port role. Is it a server port? Is it a storage port? Is it an uplink port? Right? And we have to do it cluster by cluster, pair of fabrics by pair of fabrics. The concept changes here because now we deploy the fabrics in what we call the Intersight management mode, which is just a basic application running within the fabrics, which gives us, which provides a device connector that we use to connect to Intersight. Then all the configuration is done from here, from Intersight. So now we can create domains or domain profiles as well. So we define here what are the roles of the ports of the fabric. We define the flow control, link aggregation, system QoS, and we define it as a profile. So after we have the profile, we then apply it to the fabrics. And this is cool. Why? Because if you need to expand further in the future and you need to add an additional pair of fabrics, you just apply the policy again. So you don't need to go and reconfigure everything or set up a new configuration. You just apply what exists at the moment. And I think that's pretty cool. Now, after the moment you do that and you do apply that configuration to the fabrics, then it starts doing the usual work of discovering what's attached to that fabric or to that pair of fabrics. And then obviously it will detect the chassis. And let me show you how it looks like for an X series. Excuse me. There you go. That's our view of an X series. We can take the rear view as well, obviously. And then we can get into inventory, figure out what's inside that specific chassis. I can have a look at the modules, the backplane ports, the fabric ports, or I can get into the servers as well. So if I get into the servers, I'll realize that I have 4 of those servers currently attached to this environment. I'll pick this one, and then obviously I get into the server now. So it's the same, follows the same principle that we had on UCS Manager. So it's not that much different in terms of the way we operate, we monitor, we operate over the nodes that we have. So here's a view of my node. I can also take a top view, figure out what's going on over there, check the inventory, obviously, in all detail. And then I can see also the service profile or the server profile that is attached to this specific system. And obviously, you'll find here the policies like the BIOS policy or the boot order policy or the connectivity policy that pretty much stipulates the VNICs that we wanted to create for that specific node. So again, as you see, in terms of approach, it follows the same approach as we had before. We just expand that approach for other devices as well. And I think that's an advantage. Also to show you that, as I said before, this is not specific for X series. We do support other platforms as part of Intersight. In fact, the policy for Cisco is for every new platform that we release, it first needs to be supported on Intersight. And that's the policy going forward. Doesn't mean we're not going to keep supporting UCS Manager, because we will, and we do. But Intersight is the first thing, because that's our bet going forward, okay? Now, for instance, you can see that I have a few servers here. And while they are called UCS FI, this is just naming because they are part of an HyperFlex cluster. I also have a C220, and in fact, I think this is a C220M4. Exactly. So as you can see, yes, we do support older platforms, and it doesn't need to be an X series. Okay, exactly the same approach, the same idea, the same concept. UCS server profile as well. In this case, it's a service profile applied to a standalone server. So we're bringing the concept of pools, policies, and profiles into the standalone servers as well. Okay, and the same applies to an HyperFlex node as well. Let me show you one. And I will take also the opportunity to show you something else, which I think is really, really cool. The fact that we have moved we're moving from a monolithic application like UCS Manager to this cloud native application gives us quite a few advantages, which allow us to offer a few additional things as well to you. One of those things that I really like a lot is what we call the HCL validator. And this is us, or Intersight, automatically confirming if the configuration that you are currently running is compliant with our compatibility matrix. And it does that at all levels. First, it checks the hardware if it's compatible, so everything that you have on that server is supported, then validates the operating system as well. So is that operating system supported on this platform? And then the adapters and the firmware running on those adapters. So instead of having you asking or having you to go and have to check this manually, we do that for you. And I think this is pretty cool. There are other things we do as part of Intersight, which I believe is quite interesting. One of them is advisors, and I have to do something here, otherwise I don't see my full screen. But there is this little box here, which shows us advisors, and those are the security advisors or the bugs that we have already identified. If there is one that applies to your infrastructure, then we will let you know. So it's not as before where we send you an email and say, listen, we found a new bug, and then you need to validate if it does apply or not to your environment, and then you'll need to go press a few links, open an email, and so on. Now it's here, it's right here. If there is something that applies to anything that is under the management of Intersight, it's right over here. And in fact, there is one, and I need to ask my colleagues to fix this up. So if you click the link, you'll get information about what happens with that specific situation, where does it apply to in your environment, and what are the workarounds or solutions to fix it. And I think this is a pretty cool feature. There's another one, which is also cool, which is if you take one server and you find, hey, there is a problem with my server, I need to open a attack case, then it is as simple as clicking here and, oops, sorry, there you go, and open attack case. So this will just collect information for that specific server or other device, doesn't need to be a server, and it will automatically open a case with you, collect information, send it to our support guys so they can start analyzing the problem and figure out a solution for you much faster. Okay. Obviously, you can do the other traditional and standard stuff you can do on a server, like powering off, so the life cycle of the server. You can do another cool thing, which is installing an operating system for bare metal. And it's really for bare metal. So from bare metal, and you can do an install of a Linux, a Windows, an hypervisor. So if you take all of that into consideration and think, okay, that's cool, but I still have to do it one by one. Not really, because we brought into Intersight as well an orchestration platform, which we call Intersight Cloud Orchestrator, which allows you to build workflows that can run some of these tasks as a flow, right? And you just design it by drag and dropping tasks into your own workflow. So this is the kind of approach we're taking with Intersight to make things much easier for you and faster to deploy, more consistent in terms of configuration, and more open. And that's, I'm going to finish with this because obviously we don't have time to cover everything on Intersight. Because the way we're building it, we're making it an open platform. And I'm just going to show you something here, which I think is relevant of how open it is, which is if I'm going to add a new target, which is something that I want to manage as part of Intersight, and I claim a new target, the type of devices that I support are all of this at the moment. And that includes third-party infrastructure as well. Okay? I'm not saying that I'm going to do infrastructure management for HPE or Dell, but yeah, we do support Pure in terms of orchestration. We do support VMware in terms of orchestration as well, in terms of optimization of the applications. So it's completely different approach that we're taking with Intersight, and I think we're bringing a lot of value into it. And the final note that I want to give to you is not as part of the demo, but to show you that the fact that we moved to this cloud-native type of model allows us to deliver features much faster than we did before. So in the past, we would probably release a new version of UCS Manager every 6 months, but with this new approach, we can release features, capabilities every week, if that's the case. So I'll give you an example. This is part of the Intersight help page, shows you everything that we've released and when we have released enhancements or new features. And as you can see here, on June 24 we did, on June 17th we did, then June 3rd. So pretty much every week there is something new on Intersight. So you log out, you log in again, and well, there is something new. So with that, I'm over. I'll hand over back to you, Mr. Ernst. Thanks for your time. Hope you enjoyed it.
Perfect. Thank you very much, Andrew and Sergio. And thank you also for all the questions on the panel. Thank you very much. So let me wrap this up. I want to give you a few important points to take away and show what we have achieved with the UCS X series. First, what you have heard from Andrew and Sergio, there's nothing simpler than a cloud-managed infrastructure. If you want to manage the hybrid cloud, it all starts with Intersight. And this system has been built from the ground up.
Sorry, Ernst, maybe you want to start sharing your slides again?
I'm not sharing?
No, not yet.
I'm sorry. Here we are. So now you should see my slides. Right?
Perfect,
can you see my slides? Yeah, perfect. Sorry for that. So simpler than managing with Intersight. Again, Intersight is an integral part of the X series, and bring together, and what you have seen from Sergio, bring together on-prem infrastructure and infrastructure in the cloud with workloads and applications running on it. The second part, or the second part is future-proof, and the third part is flexibility. Almost 12 years ago, we introduced now the first chassis of Project California. UCS X is the platform we built for the next decade. Not only future-proof, but extremely versatile. Everything you saw the last 35 minutes from Andrew and Sergio has more or less nothing to do with the blades of the past. UCS X is kind of a new form of compute, extremely versatile between rack and plate with X Fabric, or some call it cross fabric. So extremely flexible. Now, if you want to go deeper for UCSX, just go to cisco.com/go/UCSX, or because we saw a couple of questions for a deep dive with Intersight, you're invited to request a demo or use the free trial at cisco.com/go/Intersight. And lastly, I would like to point out the first 200 customer offer. That is a special offering for the first to market customers. Your Cisco team, Cisco account manager, Cisco sales specialist, or your preferred partner will support you on that. With that, I would like to end today's session. Thank you very much for being with us. And also a big thank you to my colleagues Andrew Gagnon and Sergio Suscia for guiding us through the session, and Fausto Vaniletti on the panel answering all the questions. Thank you for joining us. Thank you very much. Enjoy the rest of the day and goodbye.